is. Okay, right. Here. Right. Now we're going to look at something called the uncertainty. Uncertainty, then in the certain textbook, the British textbook, they don't call it uncertainty, they call it error. Error. Okay, right. So we look at one from the practical point of view. We just look at a ruler. Now this is a meter rule, and the one here marked from here until here is 1 cm.
Mm-hmm.
Here until here is 2 cm, and from here until here is 3 cm. So the length here, each of it is the 1, 2, 3, each of it is 1 cm, right? Okay, now let's say if I have a red line, the red line starts from 0 and it ends up somewhere between these two mark here, these two
Okay.
marking here. What do you think is the length of the red line?
2.3.
Uh, you can say it's 2.3, or because at the center in between the two markings there, so you
Think
can either take
2.4
it
so
the lower one 2.3,
or the higher
or you can take the higher one 2.2.4.
4.
So somewhere between 2.3 and 2.4 lah. So then the difference between this 2.3 and 2.4, 2.4 minus 2.3 is 0.1. Now 0.1 is exactly the size of the spacing, the smallest spacing there. The smallest spacing there. So this number 0.1 cm is called the uncertainty, right? And
Mm-hmm.
sometimes it is called the error, right?
Okay.
Now we look at another from another point of view. How to look at from another point of view? Let's say if someone they tell you, hey, I have made a reading already. The reading that I have collected is 1.5 cm. Now,
Mm-hmm.
if they tell you 1.5 cm, what do you think that is the actual measurement that the person has taken? Can you guess what the person has taken or not? If that person tell you, I've taken the reading, it is 1.5 cm. Okay. So
Mm-hmm.
if he tell me 1.5 cm, then I try to think of what what are the possibilities that he can arrive at this number 1.5. It could be, you see this red line, red line. It could be like that. The length that person has taken is like this length from
Mm-hmm.
0 until the 1.5 mark there.
5.
That's why he tell me, oh, it is 1.5 cm.
Yep.
However, it could be more than 1.5.
1.4 or 1.6.
Maybe from 1.5 to 1.6, could be between that, or it can be less than 1.5, between 1.4 and 1.5. So it's somewhere between here. If a person tell me the reading, if a person tell me the reading is let's say, yeah, if a person tell me the reading is 1.5, it can be anywhere between if the person tell me the reading is 1.5, it can be anywhere between here, between 1.4 and
4 to
1.6.
1.6.
Do you agree?
Yes.
Correct, so it can be
Mm.
anywhere around that. So now I try to predict the actual value. The actual value is between 1.4 and 1.6. It can be
1.6.
written like that. X
Okay.
between, using the inequality sign. Do you know how to use the inequality sign like that? The smaller number on the left hand side,
Mm-hmm.
the bigger
The bigger
number on
number
the
on the
right hand
right.
side, then you have the symbol, less than symbol there. Now this shows you a range. The range is from 1.4 until 1.6.
Okay.
This one is actually a range. This is actually a range. But normally in physics we don't write like this. We
Okay.
write like this. We write like this.
1.5 plus minus 0.1.
Plus 0.1 is 1.6 lor. Minus 0.1 is 1.4.
1.4.
Correct or not? So normally we write this way. Okay, the red color one, we write this way. Okay, now how to get this number behind there? Plus or minus 0.1. This number 0.1 is the uncertainty. It is also called the error. It is the smallest division in the instrument. So what is, you look at this ruler, what is the smallest division here? 0.1. 0.1 centimeter. Now we look at the stopwatch. This is a old type of stopwatch, eh? Old type of stopwatch. Do you know how to read this stopwatch?
Yeah.
Yeah, really. You use it to time your swimming or what? They use the digital one or they use this type?
Oh, we use digital, but this one is pretty.
You only see this type in the laboratory now. No more. No, now they use the digital. But then this type is useful when you want to learn about uncertainty. You want to learn about error, right? Okay. So now this small clock round here, each division is 1 minute. Each division is 1 minute. Okay. Then over here, the big clock, the big face here, the larger one, each division here, the bigger division is 1 second. And this big division is divided into 5 smaller division. I can see from here. This is 15. Then how much is this over here?
16.
Then here?
17,
18, 19, 20.
20.
Okay, 19, 20. So what is the reading? Can you tell me? How many seconds?
18 point.
How many small division?
18.1 to 2, give or take.
So one division is 1 second is divided into 5 smaller parts. 1 divided by 5 is 0.2. Okay, now you see from here, 1 second is divided into 5 smaller parts. So 1 part is 0.2, because 1 divided by 5 is 0.2. So each of these small division is 0.2.
0.2.
Is that okay?
Yep.
Okay. So now what is the reading here? From the big clock over here, it is 40, 41, 42, 43, 44. So is this one, the clock, the small clock here. So it is 44 minutes. 44 minutes from the big clock is 44 minutes. Now from the smaller one here, how many seconds just now you told me? 18?
18.2.
18.2. What is the uncertainty?
0.2.
Plus or minus 0.2. Why 0.2? Because it is the smallest division, the smallest division here. So it's plus or minus 0.2.